In this video, I will show you how to do calculations on contingency tables using Excel. Let us start with some counts, the same as in the previous example. So let's say we have the variable sex and home language. And this can be a majority or minority. And this can be male or female. And the numbers are 24, 1, 15, and 7. So these are our basic counts. What are our marginal sums? This is for the boys and this is for the girls. And here are the marginal sums on columns. And you see that what I'm doing is I am using ranges and I'm then pulling to recreate the same sum. So if I enter B3 colon B4, it means from B3 to B4. Now, in order to calculate the expected values, which is the next thing I'm going to need, I have to multiply the marginal sums and divide by the grand total. So if I want the expected value for this one, I need a formula. I need this times this divided by this. And what I want to do is I want to fix these so that they only change in the desired direction. This one should be able to go down, but it shouldn't be able to go to the right. So I want D here to be fixed. So I add $1. This cell, I want to be able to go right, but not down. So I fix this to 5, and the grand total should be fixed for everything. In this way, when I pull to the right, this one is using the correct marginal sums. If I pull both of them down, then this is using the correct marginal sums. I can reduce the number of decimal places that I see, because that's too many, and I can copy and paste the sums, which pastes the formulas, so that you can confirm that these are conserved. So these are the expected values. If you want to confirm whether these indeed preserve the same proportions, you can always check. So this divided by this is 4.875, and then the same is true for these. And you can try the same thing on the columns. We're not going to do it right now. So in order to create our table, observed, expected, observed minus expected, and then squared, and then that minus expected, and then the sum. These are the lines that I need to calculate. So here, I want this. Here, I want this. Here, I want this. And here, I want this. So this is, I'm just going to copy again the names of the combinations of the two variables so that it's clear what we're looking at. And correspondingly here, I want this. And here, I want this. Here, I want this. And here, I want this. So this is the expected. And now I want observed minus expected, and I pull this to the right so I get all of them. And here I want this times itself. I click again and I pull to the right, and I don't need that many visible decimals. And here I want this divided by the expected. Pull this to the right. I don't need to see all of these. Actually, I could have done this. Let me just delete and do it again so that they're all pulled together. So I can only do it once. This is observed minus expected. This is the difference by itself, and this is the square deviation divided by the expectation. So I can collect all these by clicking and dragging, and just drag the whole thing, resulting in the same table. And then I just need to add all these up, sum, and I click and drag the whole range. So you see, I sum everything from G7 to J7, and this is my chi-square. Now I can look this up in the p-value calculator, the online app with 1 degree of freedom, or if you have a sufficiently recent version of Excel, you can use the Excel function to get you the correct probability from the chi-square distribution. And this is your chi-square value with 1 degree of freedom. And we want a cumulative probability, so for all the area. But actually, we want not up to that value, but from that value onwards to the tail. So we want 1 minus this. So 1 minus the cumulative probability for the chi-square distribution up to that value, which is this number. Well, that's a lot of decimals. And this should now be a familiar number. So that's how you calculate the contingency table and the chi-square test of association for this contingency table using Excel. The advantage of using Excel to do these kinds of things is that you can very easily change your data and everything is updated automatically. So this is the only place where we should intervene. Let's try to duplicate the other example with the language screening, where the relevant numbers were 13, 32, 85, and 19. And now these values are teacher ratings, and these are the clinical classifications. As you can see, the whole analysis is immediately replicated based on the new counts. And so now we can see how we can calculate our diagnostic indices, starting with the useless accuracy. Positive predictive value, negative predictive value. And I have already aligned these to the right. So accuracy of this screening is the sum of these two. The parentheses are very important because I want the whole sum to be divided by the grand total and not just the second number. So this is my accuracy. And I can set all these numbers to be shown with 2 decimal places. My sensitivity is this divided by this. My specificity is this divided by this. My positive predictive value is this divided by this, and my negative predictive value is this divided by this. So here are all my diagnostic indices in a very simple Excel sheet that will immediately update as soon as I enter new counts.